So hello everybody, I'm Thomas from the Aristotle University of Thessaloniki, and on behalf of many service providers I'm going to present this presentation together with Giovanni from SIA, Vasilios, my colleague from AUF, and Mahlatse from SALSA. This presentation is going to show the products that we have been developing, as well as the service portfolio, which is focused on South Africa. So from all the multitude of all the products and services that Africultures have been developing in covering climate, crop, drought, land, livestock, water and weather, we're going to focus on how these products have been developed that are being shown later in the African use cases, and also focusing also on those that were of special interest for South Africa. We're going to show a little bit of the technical details of how these products have been developed. Let's start with the services and products devoted to crop monitoring, which will cover crop type mapping, crop condition monitoring, forecast of the yield, and then check on the calendar and the phenology of the crops and give an early warning if needed. First of those is the crop condition monitoring, which covers some standard products such as the normalized difference vegetation index and the leaf area index, and then also some more specialized products such as the vegetation condition index, which gives a deviation of how much different is the current normalized different vegetation index that we have now in our crop, as compared to the historical minimum and maximum over many decades before. And the NDVI anomaly, which gives how much the current NDVI deviates from the long-term average, again of a long-time series of many years before. To cover this, to cover the various resolutions requested, from very high resolution to very coarse resolution covering the whole of Africa, we use various products. Some of them were very frequently updated, like every 10 days, but at a spatial resolution of 1 kilometer, and some of them at a medium resolution of 300 meters. And also on demand, there is this service using Sentinel-2 based products, which has a spatial resolution of 10 to 20 meters. Here you can see some examples covering South Africa. On the top is the medium resolution of the NDVI anomaly. It ranges from -1 to +1. Positive NDVI anomaly means that there is enhanced vegetation condition, while negative is rather poor. And we can see here that there is a low vegetation condition in the south part of the country in January, which continued in March, in the middle top. But there were also positive NDVI anomaly in the center part of the country, which covers the east of the Northern Cape and the Free State. But unfortunately, this has decreased later in July. In the lower row, we can see in coarse resolution the vegetation condition index maps, which you can see that the extremely poor condition is in the Northern and Western Cape, and that covered all this time period from January to July. While in this area, there is unfortunately a decrease in the crop condition in the late parts of March to July. And Giovanni, if you can say a few words about crop type mapping.
Yes, I can. This is one of the products that we are providing within Africultures is the mapping of the crop. Then, of course, this product is, since it's based on Sentinel-2, is not covering the whole country, but in this particular case, two specific areas, that is Bothaville and Free State. And in this particular case, of course, the product needs ground data because it's based on phenology. Then we have to extract, first of all, the phenology by using satellite data, then a historical series of Sentinel-2 images. And then from that, we can identify different type of crops. This is just one of the maps that we developed for, produced last year for Botaville, based on the ground measurements taken by SANSA in the, also in last year. This product is provided at 10 meters. Okay, yeah, you can go on. Thank you, Thomas. This is almost based on the same idea as the other product presented by Thomas before. Then is based also in this case on the historical behavior of NDVI. In this case is based on 5 or 6 years of the Sentinel-2 images. Actually, we considered all the Sentinel-2 images available since when the satellite was launched in 2016. And then based on this, we can do similar maps like the one shown by Thomas before. Then based on the actual value of the NDVI with respect to the historical values, minimum and maximum values, we can come with maps like this. Of course, in this case, since we are considering high resolution images, that we call high resolution images in meter, this product is just devoted to crop. So we are just considering only areas identified as crop areas. So this is an example, for instance, for the Botaville area. The sample refers to an image of the 13th of July 2019. So you can see from this some area where the vegetation condition with respect to the previous years was quite low, poor, and other cases in which it was in good conditions. Okay, I think you can move on the next one. We are also another product that unfortunately is not available for South Africa is the monitoring of the phenology. Actually, we take this product from the FAO WAPUR products, and we produce this in our platforms are available for the countries for which is already provided by FAO WAPUR website, but we can, if requested, since it's not available for South Africa, we can also, if it's considered of interest, a monitoring of the phenology made every year, of crop phenology made every year, we can also provide it or produce it for South Africa. Because we know how it is done, we are already doing this at high resolution using Sentinel-2, then we can do the same. But if, of course, referring to the whole country, possibly we have to decrease the resolution from the 10 meters, I don't know, to 60 meters or 100 meters, as is done also from WAPUR. Then if this is of interest, then I put here this slide just to say that if similar product is of interest for South Africa, we can develop, we can produce for you, for them. Okay, thank you, Thomas. And this is the case of the monitoring of the phenology at high resolution. Also, in this case, then what we are providing for every year, we are providing the phenology extracted from satellite images. Then the start of the season, the maximum, the day of the maximum NDVI, and the day of the end of the season. You see actually the file is containing 7 bands. So the file is made of seven bands. 3 of them are devoted to the crop of the first season, the season 1. The other 3 for the crop of season 2, and the 7th band is defining the type of crop. As you recall, possibly, I don't know if you recall actually, But we are mostly referring to 8 crops that we were thinking are the major interest for South Africa. Sorry, there is some traffic jamming in the road. Then this is an example from on the left side. We have this the map, an example, or still in the bottom of the values of the start of season, maximum NDVI is end of the season, and in this case was for the first season. And the crop type was the crop number 2. Now I cannot recall which type of crop it is, but on the other side, on the right side, you see we are also referring to the phenology. For instance, computed the previous year. We can also say at which status is the phenology this year with the referring to the previous year. So that means that we can say if with respect to the previous year, the crop is in the growing of the crop is in delay or is in advance or something like this. And this is done in, for instance, in this case, the difference is done is given in decades. So. For instance, values from -4 to 4 means that the crop is late in growing for -40 days to 40 days. So this is giving us, and this of course is computed every 5 or 10 days because it's based on Sentinel-2 images. Then every 5 or 10 days we know how the crop is, the behavior of the crop with respect to the previous year in terms of growing. So you can proceed. Okay, this is the early warning, another product that we are producing, this crop early warning. Also in this case, we have the product at medium resolution that is based actually on the in 250 meters, then on the data coming from VIRS and MODIS images. And this is a combination of 3 parameters. The status of the vegetation computed through the NDVI, the temperature, the presence of anomalies in the temperatures compared with the last 10 years, and anomalies in the precipitation compared with the previous 10 years. Then combining these quantities, we can provide a level of warning in terms of crop. Of course, in the case of the medium resolution, we are not just considering crop because the resolution, as you saw, is the 250 meters, then is more a vegetation early warning. But this product is also provided at the 10 or 20 meters based on Sentinel-2. Then in that case, we can provide directly a warning with reference to the crop. And of course, we have different level of warning according with which one of these quantities, then NDVI, temperature, and precipitation is anomalous. So if all of them, we found that all of them are anomaly condition, then very high temperature, low precipitation, low value of the NDVI, in that case, of course, we have the maximum of the warning. But if one of them, only one of them is anomalous, the condition of one of these 3 terms is anomalous, of course, the level of warning will be 3 or 2 or 1, according with how many of these elements are exceeding some the values of the 10 previous years. Thank you, Thomas. Yeah, this is just what I said before. Sorry, possibly I have to put this before the other one. Okay, then this is the case of the high resolution. Of course, you see this is an example of, on the left side, we see for instance, the mean NDVI value in the average on 6 years of Sentinel-2 images, still for Bothaville case, then in 1 decade from the 21 or to the 1st of December. And this is just show just the distribution of the NDVI averaged on this 6 year of Sentinel-2 images. On the other side, we have a combination of the just an RGB combination of this minimum, mean, and maximum NDVI value computed for the 6 previous years. Then, based on this, we can compute this early warning maps. You can go on.
Thank you, Giovanni.
Okay.
I think I will pass the floor now to Vasilios to explain the drought product.
Thank you, Professor Alexandridis. This is the drought monitoring and early warning service. It is based on a combined drought index, which uses the methodology of the European Drought Observatory. However, we use a somewhat different set of sub-indicators. So this combined index uses different sub-indicators, combines them, and produces some easy to understand signals with a color coding. And there are 3 different signals. The yellow means that there is precipitation deficit. The orange means that there is soil moisture deficit, so that a drought has progressed. And the most severe one is the alert, the red one, which means the drought has also started to affect vegetation condition. The CDIA is a product with a 10 kilometer spatial resolution, and it is issued on 10 days intervals. Usually it's being made available at the end of its decade. Next slide, please. So we can see in this slide the CDI with the gray background at the bottom in the middle and the different color codings it uses over the entire Africa. And we also have plots of the sub-indicators that are integrated in this combined drought index, which are the SPEI, Standardized Precipitation and Evapotranspiration Index, both the 3-month and 1 month. These are calculated by reanalysis data, the ERA5. And we also use remote sensing satellite data, the soil water condition index, and the vegetation condition index. And next slide, please. We can also focus on South Africa. We see the CDI of the decade of 1 to 10th of February, and also the sub-indicators, and we see that it is not issuing much of drought signals for this period. Next slide, please. And besides this combined drought index, the service also has some complementary products that are of forecasting nature. For example, it gives the precipitation deficit forecasted, giving the locations with no precipitation included for the next 7 days, and also the probability of extreme or low high temperatures. Next slide, please. And finally, coming back to the CDI, which is the main product of the drought monitoring service, we are trying to assess the product of how well it has been doing capturing past events of the last couple of years, and also to assess it as an early warning system. How well does it actually give warnings before vegetation is impacted? And that's all for this product. Thank you very much.
Thank you very much, Vasilios. Can I ask Mahlacho to present the livestock services?
Hello, everyone. I'm going to be presenting on the livestock services. So we have 2 main products, which are rangeland types maps and also rangeland condition maps. So in terms of the rangeland types maps, we are characterizing the spatial distribution of the grazing and browsing resources for the Africultures pilot countries. And as you can see there on the map, you can see the distribution of the grazing areas. So technically, for those who are interested in the technical details, we are using multi-sensor data from thematic mapper, operational land imager, and Sentinel-2. We actually harmonize it first, so to the same resolution at 20 meters. and the same coordinates. And then we use South African land cover database as the reference map to select the sample areas and use the machine learning to actually classify these areas. And for the other countries in Africa where there's a lack of data, high resolution data, we use the annual Moody's data where we select various points within the data and we assess the samples in terms of their similarities using statistical analysis, and we can allocate those samples to either grazing or browsing areas before we can classify using machine learning. So for South Africa, as you can see on the table, you have for much good accuracies for most of the provinces except for the Western Cape, which is just about 65%. So the rangeland condition maps, we're providing high resolution, actually multi-scale data sets from various sensors and resolutions. So for the high resolution part, we are providing the LAI, the chlorophyll content, the fractional cover. So all these products are actually providing, or they are known as the indicators of the rangeland health, as well as the NDVI, and you are able to evaluate the status of the rangelands over time and their evolution over time. Thanks very much.
Thank you very much, Watson. We can now move on to disaster and start with the burned area maps. Giovanni?
Sorry. Okay. Sorry, it was a call on the phone. Okay, so let me back. So here we are, another one of the products that we are providing through Africultures is the estimation of the burned area. Actually, this is done at medium and also high resolution, but as Thomas said, the one at high resolution is, let me say, made on demand. Then if someone is requesting, we can provide it. Now for testing the procedure, we are providing the one at high resolution just for Tunisia. Instead, the one at medium resolution that is coming from the Copernicus product provided within the Copernicus, one of the Copernicus services, is this one at medium resolution. Actually, what we are providing is not just the burned area computed every 10 days, but also an accumulation of the burned area along the year. Then at the end of the year, we can compare the behavior of, the affected area of this year with the previous year or 2 years before and so on. Then this becomes easy to compare one year with the other one. But we are also providing an estimation of the area, the type of vegetation affected by the fire. Then we have this burned area, the one that we call accumulated burned area, and the land cover of the burned area. Then we are delivering these three products, as I said before. Then here we have a couple of examples for South Africa. In the right, the one on the left side, we have reported the burned areas together with the hotspot provided by, also hotspot taken from the, the firm's website, in which VIRS and MODIS thermal anomalies, or if you like, active fires are made available. Detected by satellite are made available. You can go on the following one.
Thank you.
Okay, this is what I said before. Then present time is produced for Tunisia continuously every 5 days, because it's based on Sentinel-2 images, and then is provided for on demand, can be of course computed everywhere. Okay.
Thank you, Giovanni. Let me present the flood mapping, which we do using VIRS data provided by various sources at 375 meter spatial resolution. We cover the whole of Africa. And what we get from that is pixels classified as dry land, normal open water throughout the year, flood water, or cloud and snow, and then flood water fraction, which is a percentage of flood for its pixel, wherever it's applicable. And by downloading all these products and putting them in a time series, we can have interesting results, such as those provided now on the next slide for a case study of flood in between Pretoria and Johannesburg in February 2020. In the red boxes, you can see the area where it started to get flooding in the beginning of February 2 years ago. And then in the middle image, you can see areas where it has started to decrease the flood in green, but other areas where new flood has appeared in the red box. And finally, at the end of February, you can see that almost all areas the flood has receded. And now we can go to lake water quality by Giovanni.
Yeah, this is another one of the products concerning water. In this case, also this is taken from, actually is taken from Copernicus. And in this case, we are providing two parameters that are in some way characterizing the water quality. Of course, what we are measuring, since we are using satellite images, is the apparent status of the lake. Then we are measuring some characteristics of the water that are affecting the reflectance of the water, of course. Then can be detected from satellite. In particular, the two parameters we are considering are the turbidity. There are written three, but actually one is the surface reflectance is producing the other two. One is the turbidity of the lake, that is describing the water, the clarity of the water, and the other one is the trophic state index. That is giving an idea of the productivity of the lakes and the presence of chlorophyll or other kind of substances in the lake. Since this is based on medium resolution satellite images, not all the lakes of South Africa are monitored, but just some of them. Here, we just reported the three of them that are monitored. And for one of them, which I just reported some map describing the two parameters like the turbidity and the TSI. This is provided every 10 days, yeah, all along the year. Yeah, please, Thomas. This is just a general, actually the product was in some way validated, and this is just, this map here, these graphs here are just giving a general overview of the status of the lakes along the year, comparing the case of Ghana with Mozambique, Rwanda, and South Africa, one lake for each one of these countries, just to see in general how the behavior is for every one of them. Larger is the area here, larger is the change of, for instance, of the trophic state index. Then you can see that in the case of Mozambique, the presence of the status of this index is quite constant within the year. Instead of Rwanda, is changing a lot during the year, and so on. On the other side, we have the same for the turbidity. So, for instance, you see also in this case, in Rwanda, there is a strong change during the year of the turbidity of the particular lake that we take here in account, that was the Lac Burera. In South Africa, the lake that we considered was the Gariep Dam. It seems that it's not so, it's quite stable from the point of view of these two indices. Thank you. Okay, another product is the soil moisture. This is also taken from Copernicus, provided every 10 days. The resolution is of 10 kilometers. And actually, we are providing also in this case, not just the product computed every 10 days, but also an accumulation of this product. So also in this case, at the end of the year, we know how was the behavior of the soil moisture all along the year, then we can compare with the year before and so on. What is interesting, in my opinion, of course, for this product is that it was validated using measurement taken from a ground station, and the results are quite good. Yeah, this is what I like to say. Thomas, please. This is, of course, based on the historical value of the soil moisture. Of course, we can provide every 10 days the soil water condition index and compared with the corresponding values of the same period of the year before or in the 10 years before. Then in this way, we can estimate any change, sorry, Thomas, any change with respect to the year before in positive or negative direction.